Okay, for this video, I'm going to go over how to calculate molar mass of a compound and then how to use that in solving problems where you have to convert grams to moles and moles to grams. So let's do an example problem just to find the molar mass and form those equalities. So the first one is acetic acid, HC2H3O2, and it's asking us to write an equality in 2 molar mass conversion factors. So first we need to find the molar mass. And to find the molar mass, you are going to look at each of the elements, right, and each of the subscripts that go with those elements. And those subscripts are going to tell you how many moles of that element are in the compound. And so for hydrogen, push this on here a little better. So for hydrogen, we have 4 hydrogen, right? And we have 2 carbon and 2 oxygen. All right. Now you're going to need to use your periodic table to find the atomic mass. The atomic mass is going to serve as the molar mass, and multiply the subscripts by those atomic masses. So for hydrogen, for example, if you look at your periodic table, it's 1.01. For carbon, it's 12, and for oxygen, it's 16. And so if we multiply those out, we have 4.04 and 24 and 32. So to find the molar mass of the entire compound, we're just going to add those together, and we should get 60.04. And so this is our molar mass. Molar mass. All right. And so now we have the molar mass, and we can write our equality. So our equality is 1 mole of HC2H3O2, 1 mole equals 60.04 grams of HC2H3O2. That's our equality. Now we can take this equality and we can put it into conversion factors. So our first conversion factor would be 1 mole HC2H3O2 over 60.04 grams of HC2H3O2. Okay, so if we're converting from grams to moles, if they give us grams, then we're going to use this conversion factor. So this conversion factor we would use when converting to moles. Okay. Our other conversion factor would be just the flip, the flipped version of this. So 60.04 grams of HC2, H3O2. That's really bad. Let me write that again. So our other conversion factor, try this again. Our other conversion factor is 60.04 grams of HC2H3O2 over 1 mole. And I always encourage students to keep the units, the grams or the moles, and also the compound in the calculations, because when we get into the stoichiometry and you're using, two different two different elements, or plus the compound, it gets a little bit confusing. So it's always good to keep that in the units. And so this conversion factor would be used if you're converting to grams. All right, because grams is in the numerator. Here, moles are in the numerator. So whatever you're converting to, you're going to use the conversion factor where that unit that you're converting to, where that unit is in the numerator. Okay, so we know how to make our conversion factors. Let's go ahead and try an example. And so our first example is aluminum, and it says how many grams of aluminum are in 3 moles of aluminum. So how many grams of aluminum are in 3 moles? So the first thing we always look for, always determine, is what are we given? What is our given? And here's our given is 3 moles of aluminum. And so we're going to put 3 moles of aluminum over 1. And that's how we're going to start our calculation. Always put whatever you're given, we always put that over 1 to start our calculation. Now, we are looking for grams of aluminum. And so we know we're converting moles to grams. And so over here, we're going to put grams of aluminum over moles of aluminum. Now we know we need to put grams of aluminum on top because that's what we're looking for, right? We know we need to put moles of aluminum on the bottom because these need to cancel. Okay? So let's find the molar mass of aluminum. So since it's just aluminum, we're just looking for the molar mass of aluminum, which is an element instead of a compound. So our molar mass of aluminum is 26.98. So we would write 26.98 here, and that's equal to 1 mole, right? And so if we do 26.98 times 3, you should get 80.94. And that's grams of aluminum. Okay? Pretty easy. Let's do another one. So, this next one is about aspartame. And aspartame is artificial sweetener, also known as NutraSweet. And here is our formula for aspartame. It says it's asking us to find moles. How many moles of aspartame are present in 225 grams of aspartame? And so identifying our given, 225 grams of aspartame. And so we're going to take that and we're going to put it right down here over 1. 225 grams of, and I'm not going to write out the formula. Instead, I'm going to use aspartame. I'm going to put that over 1. And then we need to convert this to moles. They're asking us to find moles. So moles are going to be in our numerator, moles of aspartame. I'm going to abbreviate it. And down here we would have grams of aspartame, right? So now we need the molar mass. We need to know how many grams are in 1 mole of aspartame. And so I've included the squares from the periodic table so that we can determine the molar mass. So for carbon, there are 14. For hydrogen, there are 18. For nitrogen, there are 2. And oxygen is 5. And I got all these numbers from the subscripts up here, right? So carbon we know is 12. And over here, carbon's 12. So take times 12 and you get 168. Hydrogen is 1.01. You're going to get 18.18. Nitrogen is 14. 14 times 2, equals 28. And oxygen is 16, right? And so 5 times 16 is 80. And then we would need to add all those up, and we're going to get around 294.2 grams. And this is the molar mass. Okay, so we know we have 294.2 grams per mole. So now all we have to do is multiply through. 225 times 1, so we have 225. Oh, let's do this first. Let's cancel grams of aspartame. So we know we're going to end up with moles of aspartame. We know that we set this up correctly. So again, 225 grams of aspartame over 294.2 grams of aspartame. And you should see, or you should notice right now, that 225 divided by 294 is going to give you less than 1. And that should make sense, because 1 mole, if you have 1 mole of aspartame, you have to have at least 294 grams, right? We only have 225. So we're going to have less than 1 gram of aspartame. And actually, we're going to have about 0.76 grams of aspartame. I'm sorry, not grams. Oh my goodness. So this is moles. Sorry. So 0.76 moles of aspartame. Okay. Did some of you catch that? I hope so. So we canceled out the grams. We're left with moles. So over here should be 225 moles of aspartame divided by 294.2, and which gives us 0.76. Okay, let's try another one. One more. So the last one is allyl sulfide, the compound that has gives the odor to garlic. So how many moles of C6H10S are in 225 grams of C6H10S? And so this is what we're given, 225 grams of C6H10S. And so that's exactly what we're going to write down here, because that's our given. And again, that's always where we start when we do these problems. C6H10S over 1. Okay? And so now we need the molar mass of allyl sulfide. So let's just do that down here. I've given you all of the squares from the periodic table so you can see what those masses are for each of the elements. So for carbon, we have 6 carbon in this, 6 moles of carbon in this formula, in this compound. So 6 times the mass of carbon, which is 12. That would give us 72. And then we also have 10 moles of hydrogen times 1.01, which gives you 10.1. And for sulfur, sulfur is, we only have one sulfur atom. There's no subscript, so we assume 1 times 32. And we add those all up, and we should get 114.1. So that's how many grams are in 1 mole of allyl sulfide. And since we're looking for moles, we're going to put moles of C6H10S, 10S up here, and grams of C6H10S down here. And so we have 1 mole is equal to 114.1 grams. And if we cancel grams, we're going to get 225 grams divided by 114, or 225 moles divided by 114.1. And so if you do the math, you should get 1.97 moles of C6H10S. Okay. I hope this helped. Let me know if you have questions.